Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Eye of the Storm by Doc Logic. And you can see it because it's like a hurricane here with the winds going through. Here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have thermometers, where digits increase starting from the bulb. So you could have something like, say, 2, 4, 6, and 7 here. And that would be a valid thermometer because the digits are increasing from the bulb to the tip. An example of an invalid thermometer would be something like this, 2, 4, 6, 6, because it's not increasing from this 6 to that 6 there. And it must be continuously increasing from the bulb to the tip along the thermometer. We have white dots link two cells which are consecutive, and not all possible dots are given. So, for example, if this were, say, a 6 here, this would have to be a 5 or a 7 here, because these digits must be consecutive because there's a white dot between them, and the only digits consecutive with 6 are 5 and 7. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the one thing that stands out to me is in column 8. So 1 can only be on bulbs, because obviously there's no digit that's going to ever be, sorry, on a thermometer, 1 can only be on bulbs, right? Because on the rest of the thermometer, you're going to have 1 digit smaller than it if you're not on the bulb, and 1 obviously that has no digits in normal Sudoku, which are smaller than it. Same with 9. 9 can only, on a thermometer, 9 can only be on a tip. So the question is, in column 8, we have every other digit. We have all the cells are on a thermometer, and none are a bulb, and so therefore, where is the 1? It must be on the non-thermometer cells. So this is 1. So the question is, can we find other instances of that? In row 7, we have something similar, except that it's tips. What digits are on tips here? We have every cell is on a thermometer, and the only digit which is a tip is here. So this must be a 9. So we can do things that are similar. Let's see. Similarly, in row 6, where are the digits? Every digit's on a thermometer. Well, we have 2 tips, yes. And there's 2 tips in the row, but this can't be a 9 because this must be a 9 here. So that means this must be 9 over there. In this lower right-hand box, where is the 9? These digits are on thermometers but are not tips. This is a 9. This 9 eliminates 9 as a possibility here, so the only 9 possible in this lower right-hand box has to be there. Well, then where is the 9 in column 7? Also, none of these are tips, so this is the only tip in column 7, which means that's a 9. Where is the 9 in this upper central box? Cannot be here because of 9 in the row. The rest are on thermometers but aren't tips, so 9 has to be there. Where is 9 in this left central box? Cannot be here because of 9 in the column. These are cells on thermometers without a tip, so 9 has to be there. Which means, where's 9 in this upper left-hand box? It has to be here because of 9's in the rows here and 9's in the columns here. So that's a 9. Where is 9 in this lower central box? Cannot be. These are digits without tips on thermometers. And 9 can't be here because of 9 in the row, so 9 has to be there. And we have 8 9's, which means where's the last 9? It has to be here. Okay. Can we do that with 1's? Maybe. 1's. Okay, where is the 1 in column 7? These are digits without bulbs on thermometers, and 1 can't be here because of 1 in the box, so 1 has to be there. Where is the 1 in this lower central box? These are all digits on thermometers without a bulb, so 1 has to be there. That leaves in row 9, 1 can't be here because of 1 in the boxes. 1 can't be here because it's a thermometer without a bulb. So 1 could be one of those two. Okay. Hmm. What else can we do? In this left central box, these digits are all digits on thermometers without bulbs. And this can't be 1 because of 1 in the row, so 1 has to be one of those two. These 4 digits are all consecutive. What are the possibilities? We could have 1 here, which makes that 2, 3, and 4, because the only digits consecutive with 1 is 2. Or this could be 2, which makes that 3, 4, and 5. You could have 3 here, 4, 5, and 6. You cannot have 4, 3, 2, 1 here because of 1 in the column there. But you could have 4. Can you have 5, 6, and 7? If this were 7, the problem is this would have to be at least 8, this would have to be at least 9, and then would not increase from this digit to that digit there. So it cannot be 4, 5, 6, 7. Can't be 5, 6, 7, 8 either. So this could obviously just go down. So we could have 5, 4, 3, 2 as possibilities. Again, cannot be 4, 3, 2, 1 there. This could be 6 technically, because you could have 6, 7, 8, and 9 there. You could go 6, 5, 4, 4, and 3 there. Can you have 7 there? You cannot have 7 there because you have to have 3 digits greater than it, and 7 only has 2 digits greater than it in normal Sudoku. So those are the possibilities. That means this digit must be less than this, or sorry, greater than this. So this is at least a 4. This is at least 5, and we have at least 6 here. And this is at most 8 because it cannot be 9 because of 9 in the box. This is less than that, so 7 at most. This is 6 at most. So then this has to be 4, 5, and 6 as possibilities. 5, 6, and 7 as possibilities. This is greater than that, so it has to be at least 3. This is at least 4. But it can't be a 4. 4 is not consecutive with 5, 6, 7, or 8. So this actually has to be 5 at least. At most, this is 8 because it must be less than 9 at most. This must be less than 8 at most. So this is 3 through 7. This is 5 through 8. What about these digits? Where is 2 possible in this box? These digits have at least 2 other digits smaller than it, so 2 can't be either of these. And this digit has at least 2 digits smaller than it, so therefore 2 must be here. Okay. This digit is greater than 2, so it must be at least 3, at least 4, at least 5. And this is a normal thing that I usually do with thermometers. I was hoping to try to find other ways of solving it, but I don't think that's really possible in this situation. Is you go from the bulb to the tip, looking at the smallest possible digits, and then go back from the tip to the bulb, looking at the largest possible digits for each cell. And from then you can fill out the rest of those cells by the digits in between. So this digit could be 8 because it can't be 9 because of 9 in the box or row. This digit is less than that, so it must be at least 7. This digit must be less than that, so it's at least 6. So we have 3, 4, 5, 6 here, 4, 5, 6, 7 here, 5, 6, 7, 8 here. And this digit cannot be a 1, because if it's 1, it's not consecutive with 5, 6, 7, or 8. So where is the 1 in row 9? It has to be here. And 5, 6, 7, 8 is only consecutive with 4 through 8 here. We have a 4, 5, 6, 7, 8 quintuplet in this lower left-hand box. That eliminates 4, 5, 6, 7, 8 in the rest of the box. So the rest is 2 and 3, and this can't be 2 because of 2 in the row. So this must be 3 here, and that must be 2 there. Okay. Remaining digits in column 1 are 4 through 8. And this digit must be less than or greater than this, so this can't be 4 and this can't be 8. This digit has to be less than a digit here, but it can't be 9. So this is 5, 6, 7, 8. And oh, I guess we should have done that way. Where was 1 possible in row 6? That made things much easier. 1 was only possible here in row 6 because these are not bulbs. These are not bulbs. These 2 digits are consecutive with 2 unique digits, and 1's only consecutive with 1 unique digit, number 2, and this can't be 1 because of 1 in the column. So maybe I didn't have to do that. So this is 1, which makes that 2, 3, and 4. Okay, so no more 1 there. That eliminates 4 in the rest of the row, so this can't be 4. This must be greater than that, so it can't be 5. Therefore, this is 5 through 8 remaining in row 6. This digit must be greater than that digit, so it has to be at least 6, at least 7 here. This is 8 at most here, 7 at most. This can't be, this has to be less than that digit, so it's 5 or 6. This is 5 or, since this is 5 or 6, if this were 6, that would force this to be 5, and it would eliminate all possibilities for that cell there. So this can't be 6 there. This is greater than that digit, so it has to be at least 6. Cannot be, it has to be less than 9. So this is at most 8, so 6, 7, 8. That means this can't be 8 here. Where is the 8 in row 6? It has to be here. We also have a 6, 7, 8 triplet in this lower right-hand box. That eliminates 6, 7, 8 from the rest of the box. So we are left with 2 through 5 here. Now this can't be 2, this can't be 2. This digit is greater than that, so this can't be 3, which means this can't be 5 there. Okay, this is greater than that, so at least 3 here, at least 4 here. This is 8 at most because of 9. 9 can't be there because of 9 in the row. This has to be less than that, so it's 7 at most, so it's 3, 5, 6, 7, no 4. This digit is less than that, so it's 5 at most here. It could be 2. Okay. 8 eliminates 8 in the rest of the column here. So where is 8 in this lower left-hand box? Cannot be here because of the way that the thermometer works. No 6 here because of no 8 here. So it has to be one of these two, and 8 is only consecutive with 7 or 9, and 9 is taken in this box. So this must be a 7-8 pair, which eliminates 7 and 8 in the rest of the box and column. Therefore, these digits are consecutive. Well, this is either 4, 5 or 5, 6, which means 5 is one of these digits. That eliminates 5 in the rest of the box. This digit must be smaller than this one. And if it were 6 here, that would not be the case because 6 would force this to be 5. So this can't be 6. This is 4, which makes that 3. That eliminates 3 in the rest of the box here. This can't be 4 either, so this is a 5, 6 pair here. So that eliminates 3 and 4 in the rest of the row. So this can't be 3 or 4. It's 2, 5 as a pair, which eliminates 2, 5 in the rest of the row here. So this can't be 5. This is 6, which makes this 5. 6 eliminates 6 here, so it's 7, which forces this to be 8. 2 and 5 eliminate 2 and 5 here, so it's 4, which forces this to be 3. Okay. 7 eliminates 7 in the rest of the box. So this is fine. We have a 6, 7, 8 triplet in row 7, which eliminates 6, 7, 8 in the rest of the row, so no 6 here. This is 4, 5 as a pair. That eliminates 4 and 5 in the rest of the box, so this can't be 5. It's 6. Okay. No more 8 here. These digits are consecutive. These digits are consecutive. Well, what does that mean? The only digits that can be consecutive that are remaining are 1 and 2, 2 and 3, or 3 and 4. But we have 2 pairs of consecutive digits. So that leaves us 1, 2, and 3, 4 together. And that means the only digit remaining is a 7. So this has to be a 7 here, which means this has to be greater than 7, so that's 8. So no 7 or 8 here. This digit must be greater than that, so no 6 there. One of these is a 7. We're not sure which. And this is a 1, 2 pair, or it's a 3, 4 pair. Well, this can't be 1, so this can't be 2 here. This could be 3, 4, or this is 1, 2 here. We're not sure. Okay, this can't be 1 and 2 because of 1 in the box, so this must be a 3, 4 pair, which eliminates 3, 4 in the rest of the column. So this is 1, 2. This 3, 4 pair eliminates 3 and 4 in the rest of the box. So it's 5, 6, or 7 here. Where is the 4 in column 1? It can only be here. So that's 4. This digit must be less than 3 or 4, but it cannot be a 3 or 4. So that leaves a 2 there. And we have 5, 6, or 7 here as a possibility. Cannot be 7 because of 7, 8 pair in the column. This is 5 or 6. We have 3, 5, or 6 remaining in column 3. Okay. 2 eliminates 2 here. Where is a 2 in this right central box? Cannot be here because of 2 in the rows. And this digit can't be 2 because it has a digit smaller than it, but 1 is not available. So if it were 2 were here, this would not have a digit possible there. And this digit has 3 digits smaller than it. So this can't be 2, so therefore 2 must be there. Where is 1 in this upper central box? I guess I should have found that earlier. That's not true. That's why. 1 cannot be... Well, never mind. Yeah, okay, that's why I didn't figure it out. Let's just do the thing that I normally do with thermometers. Okay, so these digits are 1 through 6. Well, actually, I guess we're not quite doing that, but... No 2, 3, or 6 here. No 2, 3 here because of 2 or 3 in the column. No 1 or 4 here because of 1 or 4 in the column. No 1, 2 here because of 1 or 2 in the column. No 1 here because of 1 in the column. So how does this increase? So you have 2, 3, and this has to be at least 4. And this must be at least 5 then. This digit has to be 8 at least. Sorry, at most, because we have a 9 in the box. So this could be 5, 7, 5 through 8. This digit can only be 6 at most, so therefore this is smaller than that. Cannot be 6. This is smaller than that digit, so no 5 or 6. So this is 2 or 3 there. No 3 or 4 here because of 3 or 4 in the column. Let's go this way. 1, this can't be 2 or 3. It's 4 at minimum because of 2 or 3 in the column. This digit must be less than that, so it's at least 5. This could be 8 at most here because it's less than 9. This digit must be less than that, so it's 7. So this is 4 through 7 here, 5 through 8 there. No 7 here because of 7 in the column. This digit has to be greater than this digit, so this is 2 at least. This could be 3 at least, 4 at least. This is 8 at most, 7 at most, 6 at most. No 4 here because of 4 in the row. So this is 5 at least. We have a 5, 6, 7, 8 quadruplet in column 8, which eliminates 5, 6, 7, 8 in the rest of the column. So this can't be 5 or 6. It's 4. That means this is smaller than that, so it's 3, which makes that 2. So no 2 here, no 3 here. This is less than that, so it has to be cannot be 5. We now have a 6, 7, 8 triplet in column 8, which eliminates 6, 7, 8 in the rest of the column. So no 6 here, it's 5. That eliminates 5 from being here. 3 eliminates 3 from being here, so this is 4. 2 eliminates 2 here, so it's 5, which makes that 2. 5 eliminates 5 in the rest of the row and box. This digit must be greater than that, so it cannot be 6. No 5 here. We have a 2, 3, 4 triplet here, so no 4, no 4, no 2 here. Okay. 5 eliminates 5 here. This digit is greater than 6 or 7, so this can't be 6. We have a 7, 8 pair now in column 8, so this can't be 7 or 8 here. So this is a 6. 4 eliminates 4 here, so this can't be 5 because this digit must be greater than that. Where is 2 available in column 8? Cannot be here because of 2's in the boxes. Can't be here because of thermometers, so 2 has to be here. Which means this can't be 2, it's 1, which is consecutive with 2 there. 2 only has 1 smaller than it, so this must be 1, so no 1 there. We have a 6, 7 pair remaining in column 7. That eliminates 6 and 7 in the rest of the column, so no 7 there. It's 8, which makes this 7, which makes that 8. 8 eliminates 8 here, so it's 7 and 8 there. Where... Well, we don't have any information. Never mind. Okay, this digit has to be 3. That's the only remaining digit in column 8. Cannot be 4 or 5 here, so you could have 6, 7, 8 there. Remaining digits in column 9 are 5 through 8. 4 eliminates 4 here, so that's 3, which makes this 4. Remaining digits, the rest is, well, yeah, the rest is just basically normal. Well, okay, we need this. So this digit is greater than that. It's not normal Sudoku anyways. So it's 4 through 8 here. No 6 because of 6 in the column. Remaining digits in row 5, we have 5 through 8. No 6 here because of 6 in the column. No 7 here because of 7 in the column. Where is 3 in this upper central box? Can't be here because of 3 in the column. Can't be here because of the thermometer. Can't be here because of thermometer. And can't be here because of 3 in the row. So 3 has to be here. So this is 3, which eliminates 3 here. It eliminates 3. Ugh. 3 has to be here. And that eliminates 3 here. Where's 3 in this upper left-hand box? It must be there. Remaining digits of column 6 are 5, 6, and 8. This can't be 5 because of the way the thermometer works. So 5 has to be one of these two in column 6. That eliminates 5 in the rest of the box. So this is 7 or 8. We have 1, 5, 6, 8 remaining in 1, 5, 6, 7, 8 remaining in row 4. But again, these can't be 5 because 5 is guaranteed to be one of these two. No 6 here, no 8 here because of 6 and 8 in the column. Um, 8 eliminates 8 here. Okay. Huh. If this were 6, that would force this to be 5, and that force that to be 1. But that would eliminate all possibilities for... Oh, this... Sorry, 3 means this has to be smaller than it, so it's 1 there. Which makes this 5 here. This must be greater than 5. It's 6 or 7. That digit must be greater than that. If this were 6, that would be smaller than the 7 that's allowed here. So this can't be 6. It's 8. That eliminates 8 in the rest of the column. This becomes a 5, 6 pair, which eliminates 5 and 6 in the rest of the box. So no 6 there. We also have a 5, 6 pair in row 4, which eliminates 5 and 6 in the rest of the row. So no 6 there. 5 eliminates 5 here, so that's 4 and 5. 4 eliminates 4 and 5 there. 8 eliminates 8 in the rest of that box, so this is 7, which makes this 6. Which makes that 7. 6 eliminates 6 here, so it's 5, which eliminates 5 there, so it's 6. 6 eliminates 6 here, so it's 7. This can't be 6 or 7, it's 5. This can't be 5, it's 6. 6 eliminates 6 here, so it's 5 and 6. 7 eliminates 7 here, so it's 8. No 7 or 8 here means this is 1, which makes that 7, which makes this 8. That means this can't be 6 or 8, it's 7. 7 eliminates 7 there, so it's 6. This can't be 5. That makes that 6. No 6 or 7 there means that's 5, which leaves this as a 4. And that's how you solve it. Yeah, fairly straightforward. Yeah, in the end, I had to go to my go-to with thermometers. I mean, there's a reason why I do it often. I was just looking for a way to go through a different path, but unfortunately, that wasn't the case to be here. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.